2.2. And we're going to talk about conditional statements. So conditionals, you'll hear them called conditionals, you'll hear them called conditional statements. They really mean the same thing. Conditional statements are really one of the foundations of logic, foundations of reasoning. You hear them used in legal arguments. You hear them used when politicians talk. So they really have to do. They're really an important part of using logic to solve problems, using logic to make an argument. So first off, we're going to define what we mean by a conditional. And conditional statements mean the same thing. A conditional statement is something that we can write as if then. We write it in the form if then. That makes a conditional statement. We write these in symbols, and we like to use in logic, we always use P's and Q's. Don't know why exactly that is, but we write it this way, and we would read this if P, then Q, or P implies Q. And P and Q are just some statement. If the grass is green, then the sun has been shining, something like that. So P and Q are just some phrase that we put in there that we're connecting this with. So this, we read it if P then Q, or P implies Q. And we're going to talk about the parts of a conditional statement. A hypothesis is the part of P after if. So the hypothesis is the part of P after the word if. We don't include if, and we call the other part the conclusion. The conclusion is the part of Q after then. So this is anytime we have something that we can write as an if and a then, we have a conditional statement or a condition. A hypothesis, the first part after if, and the conclusion, the second part after then. We don't include the if and the then in the hypothesis or the conclusion. And we can draw this, we can write it out, we can also draw this in a diagram. So if we draw this in a diagram, we call it a Venn diagram. A Venn diagram for a conditional statement would look something like this. So what this is saying is that if we know that P is true, if we have P, it's inside of Q. It's also part of Q. So if P were, my car is a Camaro, we could say then your car is a Chevrolet. So if it's a Camaro, it is also a Chevrolet. This is how we can draw this in a diagram. So all of these things mean the same thing. Diagram, this, or this all mean the same thing. They all tell us the same thing. So let's do a little practice with conditionals, and then we'll talk about deciding what we call the truth value. So any questions on what a conditional is? So I'm going to say, I'm going to write this statement: if a number is even, then it is divisible by 2. So what's the hypothesis here? Can you help us out? Dave, can you help us out? The hypothesis? So we can say it has to do with an even number. So we just look at this first part after the word if. So our hypothesis is this first part after if. So it is a number is even. And the conclusion? What would our conclusion be? It is divisible by 2. Very nice. So if this is our conditional statement, our hypothesis is a number is even. So I could also label it like this if I wanted to. This part is P, and this part is Q. The hypothesis is the P part, and the conclusion is the Q part. So let's write this next one as a conditional. I'm going to say, just make a statement. Adjacent angles share a side. And we want to rewrite this as a conditional statement. So I'm going to write if something. What do I want to write after my if? Anything like if angles are adjacent, or if the angles are adjacent. And then we're going to write then. And what comes after then? They share a side. And our hypothesis here, I'm just going to write HYP for hypothesis. What would be our hypothesis? The angles are adjacent, or angles are adjacent. Just the part after the if and before the then. And the conclusion? They share a side. So this is how we construct conditionals, and also kind of how we take them apart. So we just turn it into an if-then statement. Conditional means if-then. The part after the if is the hypothesis. The part after the then is the conclusion. Let's look at this first one. This first conditional statement. If a number is even, then it is divisible by 2. Is that true? Is there an even number that is not divisible by 2? No. Even numbers are divisible by 2. So this would be a true conditional statement. We'll get to that in just a second. How about if angles are adjacent, then they share a side? Is that true? What was the everyday word that we used to describe adjacent angles? What did we say they were? Next to? So if they're next to each other, do they share a side? Yeah. We said that adjacent angles had to share a side. So that would be true also. So when we look at a conditional statement and decide whether it's true or not, we're trying to decide what we call its truth value. The book calls it its truth value. So truth value of a conditional statement is either going to be true or false. So we decide if the statement's true, or we decide if it's false. It can only be true or false. It can't be true and false at the same time. That doesn't make sense. For a conditional to be true, every time the hypothesis is true, the conclusion has to be true. Every time. So when we talk about the even numbers, every time we have an even number, no matter what even number we can think of, it is divisible by 2. So that's what makes that conditional statement true. Because every time we have an even number, we know it's divisible by 2. And same thing for our other one. If we have adjacent angles, that's what we said. Adjacent angles had to have a side in common, had to share a side. So every time we have adjacent angles, they share a side. So that's what makes that true. To show that a conditional is false, what do you think would show a conditional to be false? The conclusion isn't true and the hypothesis is true. That is the technical definition. What have we done to show that something is false? Something's not true. What did we find on our opener? What was the point of doing our opener? We found a counterexample. To show that a conditional is false, we find a counterexample. And how many counterexamples do we have to find? Only one. One counterexample shows that our conditional is false. We said for our conditional to be true, that it has to be true every time. If it's not true once, then our conditional statement is false. So all we have to do to show a conditional statement is false is find one counterexample. It's nice if we can find more than one, but all we have to do is find one. So let's look at the truth value of this conditional. If you live in Miami, then you live in Florida. Is this a true conditional statement? Jordan says yes. Everybody agree? So every time you live in Miami, you're living in Florida. So we could say yes, this is true. Now, what if I told you that there was a city in Ohio called Miami? I think there is. So then if you knew that, would this be true? Because you could be in Miami, Ohio. So we're assuming that they mean Miami, Florida. that we don't know about, some little town in Ohio called Miami. I don't know if it's little. But there could be a town in Ohio called Miami. And then, if you knew that, then that would be your counterexample. My counterexample is the city Miami in Florida, or in Ohio. If you're in that city, then you're not in Florida. So that would be a counterexample. How about this one? So we want to know if it's true or false. If it's false, find a counterexample. If a number is divisible by 5, then it is odd. So we want to know if that's true or false. We want the truth value. If it's false, we want a counterexample. What do you think?
False.
Very nice. This is going to be false. Because 10 divided by 5 is 2. So 10 is divisible by 5. 10 is not odd. So there's our counterexample. 10 is our counterexample. So the truth value of this would be false, and our counterexample would be 10. And we can find lots of counterexamples for this one, right? 10, 20, 30, 40, any multiple of 10. All right, so that's what we mean when we want to find the truth value. If it's true, it needs to be true every single time. If it's false, it only needs to be false for one case for it to be false. All right, questions so far? All right, what we want to do next is talk about some other statements that we can make from conditionals. So we know a conditional is something that we can write as an if and a then. Hypothesis is the part after the if. The conclusion is the part after the then. For it to be true, it has to be true all the time. For it to be false, we find one counterexample that shows it's false. All right. So what we're going to do to make other statements is talk about this thing called a negation. Negation is just a fancy way of saying the opposite, or not, basically. So negation means the opposite. The opposite of a statement. And we write this, we have a special little symbol, this little squiggle, and we read that as not P. So not means the opposite. So an example, if I say the sky is blue, the negation would be the sky is not blue. Just the opposite. That's all we're doing. And for a lot of statements, all we have to do is put the word not in front of it. And we are going to use negations to write statements that are related to conditionals. So I want to make a little chart here. All of our statements that are related to conditionals. So our conditional, we said, was if P then Q, or P implies Q. Our first relative of a conditional is called the converse. And we form the converse just by changing the order. We reverse the order. So I'm going to write Q implies P, or if Q, then P. So the converse just means I've switched the order. The inverse. I just put a not in front of the P and Q in the conditional. So I'm going to write this, and I would write if not P, then not Q. So the converse, I switch the order. The inverse, I put a not in front of the P and the Q. And then we have one more, is called the contrapositive. The contrapositive, we put a not in front of the P and Q in the converse. So for the contrapositive, we turn it around and then put a not in front of the P and Q. So we would write it as not Q implies not P. And we would rewrite if not Q, then not P. And I'm going to write, or I'm going to circle these, two of these in red and two in blue. The conditional and the contrapositive are the same statement. They tell us they have the same truth value. And the converse and the inverse have the same truth value. So if the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false. So they're related. They're exactly the same. And if the converse is true, then the inverse is true. Converse is false, the inverse is false. They're related. They mean the same thing. And we say that the conditional and the contrapositive are equivalent statements, which means they have the same truth value. So the ones I put in red are equivalent. That means they have the same truth value. And the converse and the inverse are equivalent. They have the same truth value. So I want to do a little bit of practice with the conditional, the converse, the inverse, and the contrapositive. So we're just going to work with one conditional statement and make a converse, an inverse, and a contrapositive, and talk about whether or not they're true or false. So this is my favorite conditional. If you are a math teacher, so this is my conditional. If you are a math teacher, then you know algebra. So that's my conditional statement. Is this conditional statement true? What do you think? So right, in order to be certified as a teacher, you have to pass some tests that show that you know basically all of high school math. So we would hope that if someone's teaching math, that they would know algebra. So we're going to say that in order to get certified as a math teacher, you have to pass a test that says you know algebra. We're going to say this is true. Now we want to form the converse. So for our converse, what do we do to make our converse? So our converse, we switch the order. So it would be just like Ashley said, if you know algebra, then you are a math teacher. I'm going to underline this. Is this a true conditional statement? No? What would be our counterexample? We talked about this the other day. Anyone in this class, hopefully. So this is false. Our counterexample is students in the class. So that would be our counterexample. Now we want to, and I'm going to underline that one in blue. Now let's form the inverse. To form our inverse, we just put a not in front of the hypothesis and the conclusion in our original conditional. So how would we write our inverse? If you are not a math teacher, if you are not a math teacher, then you don't know algebra. Is this true or false? False. This is also false. And what would be our counterexample here? Kids in the classroom, same counterexample. We can use the same counterexample. These two mean exactly the same thing. So our counterexample is the same. So these two are equivalent. They tell us the exact same thing. The contrapositive. So we're going to form the contrapositive of this statement. Contrapositive, we put a not in front of each part of the converse. So how would I write that? If you do not know algebra, then you are not a math teacher. And is this one true or false? If you don't know algebra, basically you're disqualified from being a math teacher. So this would be true. At least we hope it's true. So this is the same as our original. They have the same truth value. They are equivalent statements. They tell us the same thing. The conditional and the contrapositive tell us the same thing. The converse and the inverse tell us the same thing. And notice that if the conditional is true, the converse is not necessarily true. Here's our conditional, we know that's true. The converse is not true. Sometimes it turns out that the converse is true, and that gives us a special situation that we'll talk about on Thursday. But generally, the converse, the conditional and the converse are not both true at the same time. They don't necessarily have to be true at the same time. And that's a mistake that a lot of people make with all kinds of different logic, is thinking that the conditional statement and the converse mean the same thing, and they don't necessarily mean the same thing. The conditional and the contrapositive tell us the same thing. The converse and the inverse tell us the same thing. But the conditional and the converse do not necessarily have the same truth value. All right, questions? So just a quick recap. Conditional statement. Statement that we can write as an if and a then. The hypothesis, the part that comes after the if. So here our hypothesis would be you are a math teacher. The conclusion, the part that comes after the then. You know algebra. Truth value, just deciding whether it's true or false. To show that a conditional statement is false, we find a counterexample. And we just need one. And then we use the not, the negation, to form our different relatives of the conditional. All right.